Okay, so we're going to move on to more advanced programming concepts that are necessary for you to understand to get at and understand some more complicated notions within the R programming language. We're going to be talking about classes. I have been neglecting this. I think I have mentioned it from time to time that we're going to talk about classes today, and then also methods. Then we'll talk about attributes of objects, and then how we can apply these concepts for handling more advanced functions that we write or use within an R environment. And then we're going to talk about error recovery, which is really essential as well. So remember, everything in R is an object. A class is just that definition of an object. It's kind of like it's just a classification system, a taxonomy, as you will. Okay, so a method in R is just a function that performs something on an object of a particular class. So a generic function is used to determine the class of its arguments and select an appropriate function or method. And then generic function is going to have a collection of methods. So I'm going to show you a little exercise here that will get at what I'm talking about and kind of give you a little bit of insight about the relationship between classes and methods. Okay, so for example, there's a stored data set within R called tooth growth. This data set is going to look at the effect of vitamin C on tooth growth for, interestingly enough, guinea pigs. This is going to be, by the way, an S3 class and method, which we'll talk about S3 versus S4 in just a moment. So let's use our taxonomy here that we've developed. Tooth growth is an object. Okay, the class of tooth growth is data frame. Okay, so how we describe tooth growth or classify tooth growth is another way of thinking about what that class is. But its class is data frame. Summary is a generic function, and it's going to look at the class of the object it operates on to know what to do. So let's, if we run summary on tooth growth, it's going to summarize the contents of tooth growth. We'll see that in just a moment. Versus if we are to run a linear model to maybe look at the effect of dosage of vitamin C and a factor that affects the length of the teeth, we can run summary on that model result. So this object here, fit, is also an object, but summary is going to operate differently here. Okay, so let's take a look at this. Okay, so now I'm in RStudio. I've gotten access to tooth growth, and I ran the summary function on tooth growth, and you can see right here, we just get basic summary statistics. So dose and length are both continuous scale, or numeric, I shouldn't say. Dose is not continuous scale, it's discrete. But they're both numeric variables, so we get a min, max, mean, quartiles, so forth as summary statistics. The supplement is a categorical variable, so we just get a table, 30 OJ and 30 VC. Okay? So summary operates by providing sample statistics on a data frame class object. But when the object changes, say to a linear model object, such as this fit right here, where we fit a linear model using dose and supplement to predict length, we get a different kind of result. So here, running summary on fit produces totally different results because the summary function will respond to the class of an object. So when the object is a linear model, such as fit, it does one thing. When the object is a data frame, it does another thing. That's really an important concept to make sure that you really get. So let's move on. We have different classes, or types of classes, I should say. We have lots of classes. I need to rephrase that. We have different types of classes within R. S3 classes are what I originally learned, and I still have a hard time not thinking in terms of S3 classes. It is the old style, kind of like me. It is really pretty informal, kind of quick and dirty, okay? Versus S4 style or classes are a lot more rigorous and formalized. So S3 approaches are really easy to define and implement. You add a class name to an object. I used to teach students how to do this. I'm trying to move away from it because our packages really are encouraging, if not requiring, implementation of S4 classes. You can simply define a new class in an S3 approach. There's nothing formal you need to require about the object. You just define it yourself, and it could do anything. And so it's really pretty loose and informal, but it can lead to problems because of that informality. An S4 object is more rigorous, like we said. Any object of an S4 class has to meet requirements that are specified for that class within the definition. So you have to do a lot of more upfront work with defining S4 classes than for defining S3 classes. This is partly why probably S3 classes are used more often, because they're just easier to define. So they're unlikely to disappear, but if you want to have a very well put together package in the future, you probably want to learn how to define S4 classes, and I kind of need to make that transition myself. Okay, so one reason to use S4 classes is they do reduce errors. When a function acts on an S4 class, it knows what information is in the object and can tell whether or not that information is valid. So that validation is a natural part of that class definition. Whereas in S3, you can use an object in a very inappropriate way, and there's nothing within the definition of the class of the S3 object that prohibits or precludes you from doing that. So that is a drawback. But again, it's harder to do. So the methods within I should say, consider summary. Let's start with an example. With methods that we no longer need a separate function to summarize this type of object. Instead, we have one function for summarizing a variety of object calls. So these methods are going to be, the information for the methods are going to be more clear within this structure. With S4 classes, it's easier to organize and coordinate your work with multiple contributors if you have multiple people working on, say, defining a package for R. There's going to be a lot less misdefinitions, misunderstandings due to variant class definitions and so forth. For an example, bioinformatics students probably have already heard about the bioconductor package used for microarray data processing, and they use exclusively S4 classes and methods. Okay, so in this example, we're going to create S3 and S4 classes for an infant development class called infant. These objects are going to contain information on the growth of an infant from birth to 36 months. I actually have a program that I'll attach along with this set of notes to show you the work I've done on this as well, coded myself. So the object's going to contain that ID number, the infant's gender, and a data frame with their age, their height, and their weight. So those of you who are parents have probably seen those growth charts, and that's essentially what we are going to create in this example. Okay, so here's the file S3 class example that you can run alongside here. There's a lot to type here, so I did not want to leave that part up to you for this example. So, and I also have comments to help you understand what we're doing in each step. Hopefully that will also be made clear enough in the notes. All right, so when we create an S3 class, all that we need to really do is start with defining the class attribute of the object, okay? And we use that with that class function. So this can receive a class form or report out a class type as well. To create an S3 method, we need to use that generic class function and define the class in that manner. Okay, so again, just a quick little review here. Here's some examples of generic functions. We just went over summary, but also print is an obvious generic function as well as plot. But class, unclass, methods, and str that reveals the internal structure of an object are some other examples. So let's get started on defining this S3 class for the infant context. So here we have a function that we're going to define called infant, and we're going to use this function to define our class object infant as well. So notice we have the call within here, class out. So out is our object that contains the ID, the sex, and a data frame that contains the age, height, and weight of the infant. And we're going to name that class infant. Then we use that invisible command. If you recall, it saves the results of this class when we use this infant function, but it does not report out anything. So if we run infant on an object, it'll assign the class to be infant, but it will not show you anything, which makes sense. You actually don't need to see any output from a function like this. It's just going to create that class object infant. Then we can create the print method. So this is going to mean that if we take an object that we've applied this class object infant to, and we run a generic print function, it does not have to be print.infant, it can just be print. It will print it out in this manner. So notice it's going to use this cat expression to print out the ID, the sex, and the object. The sex, and that's it. And then skip a line. And so we're going to see this very specific way of printing out what is contained in this infant class object. And then we're also going to define a plot method for infant class objects. So here we're going to create some plots. Notice the very first plot. Here we just renamed data for ease of use. We're going to create this command messes with the graphical parameters so that we can fit two vertically aligned plots on one page in R. So it'll have one plot on the left-hand side and another plot on the right-hand side. And then we create two plots. One has the age with the height. So this would be the height versus age plot. And one is going to be the age versus the weight. So these would be those growth curves for height and weight that we often see when we take our children to the doctor's office. You can see how easy this was. It really, when I used to exclusively teach this method, I would tell students, you define the class object, then make sure you always define your print and your plot for that class object. And then you're really basically done. You might have a few specific functions you want to write associated with that class object, but these are the minimum, the basics. So if we enter some data, this comes from the CDC, by the way. We have the typical ages you see on a growth curve, so age in months, 0 months, 3 months, 6 months, on up to 36 months. And then we see the average weights for males, for females, the average weights for heights and females. Sorry, the average heights for males and females. I said that wrong. We're going to create our infant objects. So here we're going to call X is going to be run through the infant function. We're going to, if you recall, let's review the infant function. We put in the ID of the infant, the sex, the age, the height, and the weight. So here we see all of that information put in. We have another object, Y, which is going to be a female. And so that X and Y, you can think of them as profiles for males and females. So then we can print the infant objects, and then we can plot them. Let's go ahead and see what the results of the printing is. And this, by the way, when we just do x semicolon y, that is identical to doing print x and print y. And then this will be the default plot.